This is part 7 of section 3.4. We've been talking about a logistic growth model, and this is our example problem. The number of people in a community who became infected during an epidemic T weeks after its outbreak is given by this function. F of T is equal to 20,000 over 1 plus A times e to the negative kt, where 20,000 people of the community are susceptible to the disease. So 20,000 is your carrying capacity. That is the maximum number of people who will ever get sick. Okay. Assuming that 1,000 people were infected initially and 8,999 have been infected by the end of the 4th week, then we're going to be asked to find the number of people infected after 8 weeks and how many weeks until 12,400 are infected. Okay, we're going to have to first find A and K before we can do any of this. So what I want to do here is I want to translate this into something we already know. So 1,000 people were infected initially. So that means at time 0, F of 0, there were 1,000 people sick. Okay. After 4 weeks, so F of 4, 8,999 people were sick. And this is similar to the problem we worked earlier with an exponential. We're going to use this information. We'll be able to find A. Then we'll use this information. We'll be able to find K. And so we'll have a better function to deal with, and we'll be able to work the rest of the problems. So let's start off by plugging in 0 for T. So F of 0 would be 20,000 over 1 plus A times, this is going to be e to the 0 power, which is 1. And this is supposed to equal 1,000. Okay, I'm going to multiply both sides by 1 plus A. So I have 20,000 is equal to 1,000 times 1 plus A. If you divide both sides by 1,000, you'll end up with 20 is equal to 1 plus A. And now subtract 1 from each side, and you'll get that 19 is equal to A. So I have improved this. Now I have 20,000 over 1 plus 19 e to the negative kt. So I know my A value. That's good. Now I'm going to find K by using this information. If I have F of 4, that gives me 20,000 over 1 plus 19 times e to the negative 4k. And this has to equal 8,999. Okay, so let's multiply both sides by this. I'll get 20,000 is equal to 8,999 times 1 plus 19 e to the negative 4k. Now this is going to get ugly, and we're going to end up having to use an approximation, but we want to keep everything as precise as possible until the very end. So I'm going to divide both sides by 8,999, and that gives me 20,000 over 8,999 is equal to 1 plus 19 e to the negative 4k. okay? Now, if you subtract 1 from this, if you get a common denominator and you subtract, you end up with 11,001 over 8999 is equal to 19 e to the negative 4k. Now, if you divide both sides by 19, which is the same as multiplying this denominator by 19, you're going to get another ugly number, which is 170,981 e to the negative 4k. And then if you wish, this will reduce, just so you have nicer numbers, to 579 over 8999 equal e to the negative 4k. Now switch this to logarithmic form. So I'm going to have log base e, which is natural log, of 579 over 8999 is equal to negative 4k. Now divide both sides by negative 4. You get that your k value is natural log of the fraction, and divide that by a negative 4. So that will be your exact answer. And then you go to your calculator and you'll get an approximation for this. And I'm going to write down several digits just so that I can get a more precise answer. And this is approximately 0.68589,157. Okay. So now my best equation would be that. Okay, so that's a lot of work, and now we finally get to do part A. Find the number of people infected after 8 weeks. Okay, so part A is asking us to find f of 8. Okay, so I'm going to take 8 and I'm plugging it in here. Oh, I left off the t up here. Okay. So that would be 20,000 over 1 plus 19 e to the minus k t. This is times 8. Okay, and if you do this, you get that it is approximately 18,541.62 people, and we don't talk about fractional people, so they're usually going to ask you to round this, and this answer will be 18,542 people. And that's how many we would expect to be sick after 8 weeks. Okay, now for part B. After how many weeks will 12,400 people be infected? So what I'm looking for is I want this to equal 12,400. Now, to make my life easier, I'm just going to write K, and then when I go to do my calculations, I will plug in the value. It's just going to make everything look nicer and be easier to deal with than writing that down on every single step. It's also asking for us to make a stupid recopying error if we keep writing that large number. Now I'm going to use the large number when I do the approximation, but not until the end. So what I have here is 1 plus 19 e to the negative k t. And I want this to equal 12,400. Okay, now I'm trying to solve this for t. So I'm going to multiply both sides by this denominator to get 20,000 is equal to 12,400 times 1 plus 19 e to the negative k t. Okay, now divide both sides by 12,400 and then reduce. So what I'm doing, and if you reduce this fraction right here, you get 50 over 31. And this is equal to 1 plus 19 e to the negative k t. Now subtract 1. If you subtract 1, you get 19 over 31. Okay. Now if I divide both sides by 19, that's going to cancel out that numerator. So I have 1 over 31 is equal to e to the negative k t. Okay. Now I can take this that's in exponential form and change it to logarithmic form. So I move the base over to here. I would have log base e, which is simply natural log. And this is negative k t. So my t value is natural log of 1 over 31 divided by negative k. And now I'll take this and plug in my k value. Okay, and then once you do this arithmetic, you get approximately 5.0066, which they're going to ask you to round, and so your answer will be 5 weeks. So after about 5 weeks, that's when 12,400 people will be sick.